We're going to pick up where we left off in the last lecture. So in the last lecture, we started talking about amplitude, frequency, period. And we said that the amplitude is a vertical shrink or stretch. So it's the same way that we transform any graph, right? We talked about transformations of other functions. Trigonometric functions is the same. So it's a vertical shrink or stretch, which means that it affects the whole function. So it's on the outside of the function, okay? A vertical shrink, which is where the amplitude decreases, we're going to be dividing. So we're multiplying by a number less than 1. So the amplitude is smaller than 1, okay? It gets smaller. When it gets bigger, okay, when the amplitude gets larger, then it's a vertical stretch. So we're multiplying by a number bigger than 1. So if we go back to those graphs that we talked about, we saw this graph here, which is, so the red graph is sine of x, and the blue graph is 3 sine of x. And you can see that the amplitude, which is the distance from the midline to one of the maximums, is 1 in the sine graph, but it's 3 in 3 sine of x, okay? So we multiplied our amplitude by 3, and it affects the y, so that's why the 3 is on the outside, okay? Then we talked about the frequency, and we said that the frequency is b, and it's the number of waves that fit between 0 and 2 pi. So right now in sine of x, there's one complete wave, meaning a full minimum and a full maximum between 0 and 2 pi. So here's your full minimum, and here's your full maximum. Okay, if we look at the nicer graph, if we look at, let's take this one out, this 3 sine of x. Okay, if we look between 0 and 2 pi, there is one full wave, a full maximum. In other words, starting at the midline. If you remember, the midline is what goes through the center of the graph. Okay, it's a full maximum, so starting at the midline and coming back to the midline, and then a full minimum. Again, starting at the midline and ending at the midline. Okay, so a full maximum and a full minimum, right now we have one wave. Now if we change this frequency and we make it, let's take some of this out. This is from the previous lesson, so I want to take some of it out so it's less confusing. We'll leave the cosine in there. Let's change the frequency. So the frequency is a horizontal stretch or shrink. So in this case, we're multiplying, so it's a horizontal shrink. And here you can see that instead of just one wave fitting between 0 and 2 pi, we actually have 3 waves, okay? We have, this is the first one, that includes a full minimum and maximum. Then we have the second one, and now we have the third one, okay? So we have 3 waves. Now we could change that. We could say, okay, let's make the frequency 1/2, 0.5. Well, now if we look, that's the blue wave. If we look between 0 and 2 pi, we have a full maximum. We don't have a full minimum. We only have half a wave that sits between 0 and 2 pi. So that's the frequency, okay? Frequency is a horizontal stretch and shrink. But then we also talked about the period. So the period is the actual length of the wave. So like in this one, from 0 to 2 pi, we have one wave. So the length of the wave is 2 pi. In this other one, this blue one, you can see that we only have half a wave between 0 and 2 pi. So the full wave has a length of 4 pi. That wavelength we call the period. Okay, so it includes one full maximum and one full minimum, and it says what is the length of that wave. So this goes from 0 to 4 pi. And the way that we can figure this out is we could say, okay, well, the frequency is the number of waves that fit between 0 and 2 pi. So let's take 2 pi and divide by the frequency. So 2 pi divided by 1/2 is actually 4 pi. And if we go back and we change this back to 3x, let's say, 2 pi divided by 3 is 2/3 pi. Now let me change this to something that is going to be easier for you to see. Let's change it to 4. So this is saying that there are 4 waves between 0 and 2 pi. Okay, we can see that. 1, 2, 3, and 4. So if we're saying there are 4 waves between 0 and 2 pi and we want to figure out the length of one wave, well, we could just do 2 pi divided by 4. And that gives us pi over 2. Okay, so 2 pi divided by 4, we're saying, okay, we'll divide this graph from 0 to 2 pi into 4 sections. And we actually do that, and that gives us the length of one wave, which is just pi over 2. Okay. Then we have our transformations. We have our translation. So this is the frequency, the period, and the amplitude. But then we can also take a sine wave and we can move it up or down. So we said, okay, let's move it up by 1. Well, if we move it up by 1, our midline also moves up by 1. I'm going to take out the sine graph for a second. This is just the sine of x plus 1. You can see that the middle of the graph, halfway between the minimum and the maximum, okay, halfway. So here's where our minimum is. Our maximum is up at 2. Halfway between there is 1. Our midline is 1. And you can see that our midline is always going to be whatever number. If we have plus 3, then our midline is going to be at 3, okay? Because we moved the graph up by 3. Our midline was originally at 0, so now it's at y equals 3. It's always a horizontal line. We can move our midline down. So instead of plus 3, we can change it to minus 3. And you can see then that our midline is at y equals negative 3. That's halfway between the minimum and the maximum. Okay, now our amplitude is still 1. Okay, we move the graph down, but the distance between the midline and the maximum is still 1. And we could see that in the equation as well, right? We have sine of x minus 3. There is no number here. We haven't vertically stretched the graph. Now let's say that we change this to 2. Well, now we move the midline down, but we also increase the frequency. So you can see the distance from the midline to the maximum, or from the midline to the minimum, is 2. Okay? And you can see that in the equation. The amplitude is 2. Now we can also translate it left and right. So let's take out this. Now when we translate to the left or to the right, we translate usually by a factor of pi, because our x-axis has a factor of pi, right? Our x-axis is in terms of pi. So we took the sine graph and we moved it to the left because we added. I'm going to show you the sine. The sine graph is this red graph. If you imagine picking up this red graph and moving it by pi over 2, notice our maximum at pi over 2 is now our maximum at 0, because we picked up this graph and we moved it to the left, okay? So we have, let's go back to our notes. We said that when we transform our sine or our cosine graph, so we can use cosine as well, when we transform our sine or our cosine graph, we can transform it in 3 ways. We can vertically stretch or shrink it, okay? So the vertical stretch and shrink is the A, that changes our amplitude. The horizontal stretch and shrink is our B, that changes our frequency, and as such our period, okay? If we change our frequency, then the length of the wave has to change. We translate it left or right, which doesn't really change much about what we identify in the wave. It just changes our It just changes its location. And then we have the plus k, which moves it up or down. And the k is telling us what where our midline is. Okay, so then we went and we kind of did, I know I was running out of battery here on my pen. So what we did is we started looking at equations and identifying things. So we said if we have 2 sine of 4x, our amplitude is 2. Okay, it's a vertical stretch, so it makes sense that our amplitude would increase. Our frequency is 4, so now there are 4 waves that fit between 0 and 2 pi. And our period is going to be 2 pi over 4. Okay, our midline didn't change. And the midline is the only other thing that we really take into consideration. The transformation, the translation left and right is not something that we can identify it, but it's not something that we use all that much in terms of identifying aspects of the wave, okay? Here we looked at another equation and we tried to identify amplitude, period, frequency, and translation. So here our amplitude is 1/3. Our frequency is 6. That's what's affecting the x, okay? And our period is going to be 2 pi over 6, which we simplified to pi over 3. This is the length of one wave. This means that between 0 and pi over 3, we have one full wave, okay? Then we took another one, and our translation, this was a minus pi over 2, so it says that we're going to the right, so this became a plus pi over 2. And we went up 8, which means that our midline is at 8, okay? Then we took another one, and we said, okay, amplitude is 7. Frequency is 2. The period is 2 pi over 2, or just pi. And here we see a plus pi over 6, which means that we go to the left. So in our notation, it's negative pi over 6. And we went down by 4. So over here, it's negative 4, which means that our midline is at y equals negative 4. And then we attempted to go backwards. So we took cosine of x, and we transformed it so that the amplitude was 1/2, the period was 2 pi over 7, and we didn't have a translation. So if the amplitude is 1/2, we put a 1/2 in front of the wave. We're using cosine, so we just have cosine. And we needed to figure out our frequency, because that's what's inside our equations, right? Inside our equations is not our period. Our period is 2 pi over b. It's the b that's in the equation. So we said, okay, well, 2 pi over b is equal to 2 pi over 7. So we could cross multiply, and that's going to help us solve for b. So we add 2 pi times 7 equals 2 pi times b. So we get divide by 2 pi on both sides in order to solve for b, and we get b equals 7. So that's a horizontal shrink. So we multiplied our x by 7. Okay. So what I want to do is I want to do some more of these, because I don't think it's all that clear in these notes, and I think it's great to practice. So let's go. We're going to return to this, and then we're going to do some graphing. Okay, how do we take what we transformed and then graph it? So we're just going to do a bunch of examples going in both directions, where we identify amplitude, period, frequency, and even midline. When we graph, you shouldn't have to worry about translating left and right, so I'm going to leave that out for now, okay? Since we already did it, and you should already be familiar with what transforming left and right is. It's affecting your x, and you're either adding or subtracting. So this is a review. It's just working with sine and cosine instead of, exponential functions or logarithmic functions. Or linear, absolute value, reciprocal functions. Transforming is exactly the same for trigonometric functions. The difference is that we have names for our vertical transformations, for our horizontal ones, okay? And notice we're not talking about reflection here either, okay? It's not that you cannot reflect. Of course you can reflect, but a reflection of the sine graph and the cosine graph is exactly the same version of the sine graph or the cosine graph, right? If we take just so that you see what I mean by that. If we take sine of x, and then we change it to sine of negative x, so the blue is the sine of negative x, what you can see is that essentially we have the sine of x, we just translated it, okay? We just did a translation. We translated it, either you could say it's pi to the right or pi to the left. It's exactly the same thing. So that's why we don't worry about transforming using reflection. And if we do it the other way, if we take negative sine x, you can see the same thing. It's a translation. So we kind of say, okay, well, if a reflection is the same as the translation, we don't really have to take it into consideration. But of course, we can reflect, okay? Okay, so let's take examples. Let's say that we are going to identify for each of these the amplitude, the frequency. We're also going to do the period, and the midline. So let's first take y equals, I could use f of x, I'm just using y. Y equals 2 cosine 6x plus 4. Okay, so we want to identify the amplitude, the frequency, the period, and the midline. So notice I didn't translate the x left or right in this one. That's because when we go backwards and we create the graphs, we're not going to be looking at translations to the left and the right, okay? So first of all, you're going to go back to this idea of a cosine bx plus k. So notice I left out the x minus h here, okay? We're using cosine, okay? Everything is the same with cosine. So our amplitude is our vertical stretch, and we can see that the amplitude is now 2. So remember, in our original cosine graph, our amplitude is 1, and our frequency is 1, and our period is 2 pi, okay? And our midline is 0. That's in the original graph. So I'm just going to put that off to the side. And this is true for cosine. It's true for sine. Okay. Our amplitude is 1. Our frequency is 1. Our period is 2 pi. 2 pi over 1 is 2 pi. And our midline is a horizontal line, and it is at y equals 0. Okay, so this is just general information. This is what we're transforming. Okay, so if we go back here, our amplitude is now 2. Our frequency, which is our b value, is equal to 6. Our period is 2 pi over, this is a b, which means in this case, it's 2 pi over 6, and you should always simplify. So this is pi over 3. And then our midline is at y equals positive 4. So it went from 0, we translated it up to 4. So our midline went from y equals 0 to y equals 4. Okay, let's take another one. Okay, so we have some fractions here. That's absolutely fine. We could have fractions. Okay, all it means is that things are getting smaller instead of bigger. Okay, so let's identify everything. Notice we use sine instead of cosine. That's fine. The reason why we only use sine and cosine is because they are waves. Okay, and waves will have amplitude, frequency, period. Whereas think about the tangent, right? Tangent, it's not a wave, so we wouldn't describe an amplitude. Okay, so here our amplitude is our vertical stretch or shrink. In this case, it's a vertical shrink, right? Our amplitude is getting smaller. I should put an equal sign. Our amplitude is just 1/7. It's 1/7. Okay. Our frequency is 1/3. Our period is 2 pi over our frequency. Now you would never leave it as 2 pi over 1/3. So you would multiply it by 3/1, right? This is like division of fractions. So the bottom cancels out. You're multiplying by the reciprocal of that second fraction. And we get 6 pi, which kind of makes sense, right? If our frequency is getting smaller, we're saying less waves fit between 0 and 2 pi. So if less waves fit between 0 and 2 pi, then our wavelength should be getting higher. It should be getting greater. Okay, so that would be another note in there, that as our frequency increases, they have an inverse relationship. Frequency and period, we call it an inverse. We even say inversely proportional, because if the frequency doubles, the period will get cut in half. If the frequency triples, the period will be cut by 1/3. If the period triples, the frequency will be cut by 1/3. So inversely proportional relationship. As one increases, the other decreases. By the same factor. That's why we say inversely proportional. If double the waves fit between 0 and 2 pi, then the wavelength has to be decreased by half. Okay, if one doubles, the other gets cut in half. Let's try another one, and this would be a great place for you to pause the video and try it on your own. So this one, again, this is really straightforward. Our amplitude is what's happening vertically. So we're looking at the value that's affecting the whole function. So our amplitude here is 8. Our frequency for this one is 1/4. Our period is 2 pi divided by 1/4, which is the same thing as 2 pi times 4, or 8 pi. So 1 is being divided by 4. So this one, the period, is being multiplied by 4. Up here, the frequency gets divided by 3, so the period gets multiplied by 3. Okay, that could be very helpful in terms of figuring out how to do it. And I'm sorry, I forgot the midline in this one. The midline up here in part B is y equals -8. We move the graph down by 8. And then the midline for C is y equals -1. So let's just graph these. Okay, so we're going to take each of these and we're going to graph it here, just so that you see what's happening. So in the first one, I'm going to leave the cosine so that you see the difference between the two graphs. And we're going to do 2 cosine 6x plus 4, just so that you could see the difference between these graphs. So we really only have to look between 0 and 2 pi. Okay, so first of all, you can see it moved up. And if we look at the midline, it is at y equals 4. That's exactly halfway between between the minimum and the maximum, right? Exactly halfway. And we can find exactly halfway by adding these and dividing by 2. We could take 2 plus 6 and divide by 2. That gives us 4. That's exactly in the middle, okay? So that's our midline. You can see that here. Now, our amplitude is 2, right? The distance from the midline to the top is 2. The distance from the midline to the bottom is also 2, okay? The amplitude is half the distance from the top to the bottom. Our frequency is how many waves fit between 0 and 2 pi. So we have 1 wave, 2 waves, 3 waves, 4 waves, 5 waves, and 6 waves. And we said, what's the period? Well, the period, it's a little hard to see over here, right? Because we're going up by pi over 4 and pi over 2, but it's actually pi over 3, okay? It's 1/3 of pi, which makes sense, okay? If 6 of them fit between 0 and 2 pi, then 3 of them will fit between 0 and pi. So 1 of them will fit in 1/3 pi. Okay, let's take the next one. So we're going to do 1/7 sine of 1/3 x minus 8. Okay, so let's see where that went. So notice that you can't see it in this window. Reason why you can't see it in this window is because we moved the wave down. We moved it down by 8. This window, as of this moment, only goes to -3. So we're going to go all the way down to 8. Okay, let's make it a little bit smaller so that you can see. So notice our midline is now y equals -8, and our amplitude is only 1/7. That's why it's so narrow. It looks almost like a straight line, right? Because it's only 1/7, and 1 is 2 boxes. That's the scale here, right? This would be -7. This is -8. So 1/7 is really small. It looks almost like a straight line. Our frequency is 1/3. Between 0 and 2 pi, here's 2 pi. Sorry. Here's 2 pi. This is only 1/3 of a wave. Half a wave goes to 3 pi. So this is only 1/3 of a wave. And that means that the period is 6 pi. So if we go all the way to 6 pi, which ends right, I messed that up. If we go all the way to 6 pi, which is hard to see, right? You finish 1 full wave, but it looks like it looks almost like a straight line. Let's see if we can make this. Can make it bigger, but as we make it bigger, we don't get as far, right? But you can see that as we go over to 6 pi, that's where we wind up over here, okay? Right back at the 0. Let's take the next one. So this one is 8 cosine of 1/4 x minus 1. And we could take this out. Okay, let's move this over. Okay, so here, where's the midline? Well, the midline is now at -1. Okay, that's the center. This goes up to 6. This goes down to -9. So our amplitude, I just want to make sure I did this right. Our amplitude is 8. So the difference between the top and the bottom, so this is at -9, this is at 6, okay? This is at 7, sorry. The distance is 16 between the top and the bottom. So the midline is 8 away. It's at -1 right here, okay? The amplitude, our midline is at -1, our top is at 7, so our amplitude is 8. And our period is 8 pi. This is where we complete one full wave. So notice for our cosine, we could look at one full wave, again, as a complete maximum and a complete minimum. So this is the 1/2 of a maximum. If we start at 0, this is 1/2 of a maximum, right? So we have half of a maximum, then a full minimum, and then the other half of the maximum. The other way that you can define wavelength is the distance between two maximums, okay, or the distance between two minimums. I don't generally define it that way for you because we're not translating the wave right now. Okay, we're not translating it to the left and the right. So I like to think about it as, what are you familiar with when you graph sine and cosine? So sine starts at 0 and cosine starts at 1. So if we think of it as, we're not really doing distance between minimums and maximums. We're saying, what is one full wave going from, for cosine, going from 1 back to 1, and for sine going from 0 back to 0. Okay. Okay. So let's go in the other direction. This is where you're given the graph and you're given the equation and you have to find this information. Let's say that we did it the other way around. Let's say that you're given the information and you have to find the equation. Okay, so let's say given the amplitude, I'm not going to give you the frequency, I'm just going to give you the midline and the period. You want to find the equation of the curve. So we'll do a few of these. Let's say, and you can start trying these on your own. You just don't even have to wait for me to do the first one. You should be able to do this at this point. Okay, so you are using, I'm going to tell you, I have to tell you which one to use, sine or cosine, right? Use y equals cosine of x. This would be called, we haven't really talked about this, but this would be called your parent function. Parent function is a function before you transform it, okay? Before you do any sort of vertical stretch, vertical shrink, any sort of dilation, translation, or reflection. So y equals cosine of x would be your parent graph. So use y equals cosine of x, use an amplitude of 3, a period equal to 6 pi, and a midline of y equals 2. So you're given the amplitude and the midline. So the only thing that you still need to figure out is frequency. This is the only thing that you have to do in order to get the equation. So we need to find frequency. Frequency is your B value. And the only way to do this is to get it from the period. Okay, so we know that the period is 2 pi over b. So 2 pi over b is equal to 6 pi. Right? That's what we're told. 2 pi over b is equal to 6 pi. And we can write this as 6 pi over 1. Okay. And then we just cross multiply because that's going to tell us what our frequency is. So we get from here 2 pi is equal to 6 pi times b. Now we need to solve for b, so we're going to divide both sides by 6 pi. So here the 6 pi's cancel, and here the pi's cancel. You should not have a pi in your frequency, okay? So your b is equal to 2 over 6, or 1/3. Always reduce fractions. So now you have enough to do this, because this is going to be your amplitude comes first, 3 cosine. Then you have your frequency, which gives you 1/3 x. And then your midline, which is +2. Let's do another one. Let's use y equals sine this time. And we give you your amplitude as 1/2. Your period as pi over 7. Your midline as y equals -5. Okay. So once again, the only thing that you need to find is you need to find the frequency. So 2 pi over b is equal to pi over 7, right? 2 pi over b is equal to our period. We're just plugging in here. So now we cross multiply. And we get 14 pi is equal to b times pi. And we're just going to divide both sides by pi to isolate the b. So the pi's cancel, and we get that b is equal to 14. So now we just plug in. Y is equal to 1/2. We're using sine this time. Our frequency is 14, and it's -5. We're translating down 5. Okay, let's do one more. It's the same process every single time. And one thing that you can do is you can practice, right? You can see if you get the right equation. So if we plug in, I'll plug in the first one. Okay, if we plug in our answer, three cosine of 1/3 x plus 2. Okay, that was the equation that we got. And what you can do is you could check and make sure that you have an amplitude of 3, a midline of 2, and a frequency of 1/3. So, or a period of 6 pi. Okay, so here, our midline, well, we go from -1 to 5. Okay, the midline is right here at 2. That's correct. It should be at 2. Okay, that was the information that we were given. Our amplitude is 3, so we go from 2 to the maximum. The maximum is at 5. The amplitude is 3. Okay, and what's our, we're told that the period is 6 pi. That's probably the easiest way to check. So if our period is 6 pi, that means one full wave goes between 0 and 6 pi. And that's true. We go from 1 back to 1. Okay, so that means that our answer is correct. So you can even come up with your own problems, and you'll see that you got it correct. If we do the other one, so the other one we found that the amplitude was 1/2. This was the equation that we found. Okay, now this is really tiny. We'll make it a little bit larger. Oh, that's okay. So here our midline had to be at -5, and it is at -5. Okay, that's exactly the center. Our amplitude is 1/2. It certainly looks like it's 1/2. Okay, and we could look at our period. We don't have to look at we could look at our period, or we could look at our frequency. So we could count the number of waves between 0 and 2 pi, and we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 waves, which is what we want as our frequency. You can also you could also check the period, like in the last one we did period because it was easier than looking at frequency. That's totally up to you, either one, right? But our frequency is 14. That's what we got. So you can see that this graph is correct. So you can make up your own problem, and then you could go to Desmos, to the graphing calculator, and you could plug in the equation and see if it matches all of the information that you made up. Okay, so let's do another one. Let's say that we have you use sine again. This time, let's make your amplitude 6. Let's make your period equal to 4 pi. And let's make your midline at y equals 3. Okay, so what do we have to do? Again, we have to find frequency. That's done from the period, right? The period is 2 pi over b. And our period is equal to 4 pi. And once again, we would write it as 4 pi over 1. So we cross multiply. This gives us 2 pi is equal to 4 pi times b. Divide both sides by 4 pi. That solves for b. This cancels. Our pi's cancel. So we get that b is equal to 2 over 4, or b is equal to 1/2. And remember what this means. This means that only half a wave fits between 0 and 2 pi. Okay? So let's write our equation. Y equals 6, because that's our amplitude. We're using sine. It's going to be 1/2 x. And we're going up by 3. And if we graph this, just to confirm, we have 6 sine of 1/2 x plus 3. Notice I have to put it outside the parentheses, right? If it's inside the parentheses, then it's going to be a translation left or right. Okay. So let's see. Let's make sure that everything is correct here. We were told our midline should be at 3. 3 is right here. Okay. That is our midline. Y equals 3. Let's see if we could, I think we could plug this in. This is clearly our midline, right? The distance from the midline to the maximum is the same as the distance from the midline to the minimum. So this is clearly our midline, okay? Then we look between 0 and 2 pi. There is half a wave, okay? We go from our midline back to our midline, okay? That's half a wave. We could check our period too. Our period was 4 pi. So we do complete a full wave between 0 and 4 pi. So that's another way to look at it. Okay. And our amplitude, well, our midline is at 3. We go up to 9, so our amplitude is 6. Okay. So notice that when we created our equation, we could verify from the graph that everything is correct.